So this is Module 1.2.1, IT Systems Theory. Steve Parenti, Professor, Department of Finance, Carlson School of Management. So we're going to talk about some fundamentals in systems theory, and it won't stay theoretical too long, but just to lay some basic ground rules of some simple procedures here. First, we're going to talk about this distinction between data, which we talk about as raw facts and figures collected as part of the normal functioning of a business, clinical encounter, or research experiment. So data can be something someone gives to you. It can be the type of thing that you manually collect on paper. It could be the type of thing that you import into Excel. But it's generally, the idea is the first word gets it all. It's raw. This is in contrast to information, which is data processed in a formal, intelligent way to obtain results directly useful to managers and analysts. So, you might get, say, a raw database that's, say, from a comma delimited file. That's data. Putting that into a nice Excel spreadsheet where you summarize things, make it a pivot table, put it into a graph, that's much more in the sense of information that you've structured it. So, in terms of systems theory, one thing we want to get straight is a few terms of the road here. So one of them is objects, and objects are known as the component parts of a system, really any system, not just information systems. And then there are the attributes, which are the characteristics of that object. So a lot of times these things might be drawn up as, a function for object is with the attributes inside of the function. So f of x, and then x is your attributes. So you see this in motion from an input to output relationship through some sort of a conversion process. So for example, if we're going from input to output, this is your input component here. We then have a conversion process, and that could be anything. That could be, this input could be that raw data file you downloaded someplace. The conversion process might be you on a computer with Excel or Access, basically with some eye toward making it better. And then the output becomes whatever you produce from that, the graphs that might be in place or otherwise. So I thought I'd think of some examples of this. I mean, it doesn't all have to be sort of a data generation process. It can simply be, you could have, say, a medical procedure where, you have your patient's clearly part of your input, and then sort of the tools that you might be doing, say, surgery, the surgeon themselves, the nurse, the equipment, all the things, and then basically the surgical procedure where all the knowledge and stuff comes together, and application and energy is all the conversion process, and the output essentially is whatever the outcome of that surgery might be. So really anything where you're going from kind of a raw materials to a finished product can sort of fit into this illustration through output. So another part of systems theory is to think about the different types of management decisions that you might run into. And so there's two different types of approaches that one can take. There's probably lots of different words you can use, but the ones that sort of boil down fairly well is the purely rational versus the non-rational. So the purely rational is where all information must be considered before a decision is made. The non-rational is where every situation is different. You're considering social, political, environment. You feel people out, kind of get a better sense of where people are going to be with all these components in terms of where they might go. If we're going to be operating in kind of a science fiction world, one could go to Star Trek, depends what Star Trek vintage you want, but going back to the original series, TOS, we could put Spock here as the purely rational person, and under non-rational, we'd actually put, instead of Kirk, we'd put McCoy, the doctor, with everything as he's a doctor, not a bricklayer, and so on and so forth. If you ever watched these old series, and they're available now on Hulu, I yes, at least my kids tell me that, then you could see this happen. But, the idea is that you have a sort of a manager that may combine both approaches, basically looking at the facts and also considering sort of the other issues that are involved as well. And that's really what the thought of a more seasoned manager. So to the extent that you overlook some of the other character traits of Kirk in the original series, Kirk kind of does both of those. He sort of considers the data, has the respect of the Vulcan and the purely logical person, but also looks into the different larger issues as well. And there's many management worlds where that type of scenario comes into play. And so the issue is that you're going to have many instances where you don't have all the information. So that could be a problem in Health IT. And another component here, the role of the computer. There are many times when people think of a computer as the end game of all of Health IT, and that's just wrong. The computer is a tool more than anything else, and that it is not a Health IT product. Many times people think of if you just put another server in, you get another application in, with that with a server component with it, you're done. So whenever you think about a Health IT business plan, it should not specify the purchase of a computer as the key goal, unless it's the foundation for the rest of the plan. Now, there could be a situation where, as I mentioned before, like you have a critical failure because your technology and your hard drives and your network cards are just way too old, and that for a very short tactical thing makes sense. But that's the exception to the rule. I mean, if you're thinking about a new system, you need to look at it comprehensively. And this concludes this module on IT systems theory.